Assalamu alaikum. Now we are going to talk about air resistance and terminal velocity. We already know by now that friction acts on moving objects. So, when an object moves through air, it experiences air resistance. Air resistance is a type of friction force when objects move through air. Air resistance is also sometimes known as drag force. So, here in this graph, I have shown the velocity time graph for a parachutist. This is the time 0. Here I have denoted different points of time by A, B, C, D, E and F. So, when a skydiver falls from the airplane, the time starts. So, at the moment he falls from the airplane, the time was 0 and there was no other force acting other than the weight force. Weight equals to mass into acceleration. This mass is the mass of the parachutist. Mass into acceleration due to gravity, that is 9.81 meter per second, is the weight force that's causing the parachutist to skydiver to fall downward. As the speed, as this force is causing the skydiver to accelerate, drag force starts to act. Because the person is moving downward, drag force acts upward on the person. As a result, the resultant force decreases. Here the resultant force is now W minus Ft. Although the resultant force is downward, it's much less than it was before. At A, when the time was 0, the resultant force was W and acceleration was occurring at 9.81 meter per second square. At B, at this point, as the velocity of the skydiver is increasing with time, is changing with time, drag force starts to act and it was lower than the weight force. As the resultant force was less than at A, the acceleration is now less. That's why the graph is sloping, slightly sloping. The slope is much less steep. At C, we can see that at point C here, we can see that the weight force is now equal to the drag force. That means the resultant force is 0. That means there is no acceleration and it's reaching the person has reached a constant velocity, and that is known as the free fall terminal velocity. After the skydiver has reached the free fall terminal velocity, he opens the parachute. As the parachute opens, a large number of drag force is acting on the person. That means now the drag force is much greater than the weight force. That is why the person is now decelerating. You might think, why is not the person moving upward? It's because friction does not friction or air resistance does not cause a person to move. It just opposes the motion of the object, and here weight force is causing the person to move downward. So, the person is now moving downward, but as a less but at less speed. The person is decelerating. In the downward direction, acceleration is negative. That means deceleration is happening. Then as deceleration is happening and speed is becoming less, that the drag force acting on the person is decreasing. At point E. And at F, drag force again become equal to the weight of the person. Another terminal velocity is reached with the parachute open. The parachute was necessary for the skydiver to land safely, because without any parachute, the person would have landed and decelerated when at a much higher deceleration. If there was no parachute, when the person lands on the floor, lands on the surface or ground, the deceleration would be much higher and it could have caused damage to parachutist. But with parachute open, the velocity is made much less. Now that the velocity is much less, the parachutist can now land safely. That's all about air resistance and terminal velocity. Thank you.